Hi everyone, welcome to my channel Understood. I'm Ben Suresh. So today we are going to see the part 2 of thermodynamics. So come let's get started. So what you been before video we saw thermodynamic system. It's nothing but in this system the fixed quantity of matter in a particular region where we are focusing for the analysis of the system. This we call it as the system. This we call it as the system, and outside system which we call it as surroundings, and the system and surroundings it is separated by the system boundary, and the system plus surroundings which we call it as the universe. So this we saw in the thermodynamic system. So fixed quantity of matter is there where the focus is taking place, and outside that surroundings, and these both are separated by system boundary, and this system and surroundings it is the universe. So this till this we have discussed. So let's move on to the next one, which is this system is classified into three types. So let's move on to the types of systems. We are just focusing only this system, okay? So in types of systems we can see that these types of systems are mainly classified based on two criteria. One is mass transfer and another one is heat transfer. Heat, or also you can say it as energy transfer. Both these criteria you classify the we classify the types of systems. So some systems may have don't have mass transfer but they have heat transfer. Some systems they have both mass transfer and heat transfers, and some systems both mass transfer and heat transfer are not possible. So on both these criteria, we are going to classify it into three systems. One is closed system, open system, and isolated system. So let's move one by one. So in closed system, what is closed system? In closed system, heat transfer takes place, but mass transfer does not take place. Now you can see that heat is moves inside, heat moves out, and mass transfer does not take place. Heat can move inside and heat can move out. Mass transfer does not take place. Always keep that in mind. For example, consider a certain quantity of fluid in a closed container. I'll show you with the diagram. So this is the diagram. So this is the closed container. As you can see here, this is the closed container. Before, don't consider this burner first. Normally while seeing this, you can say that this is a normal fluid in a container. Closed container, a normal fluid is present. This is a vessel and it is closed with the help of a lid. And now this is considered as a closed container. There may be some things while heating, the vapors, water vapor may move out, and these things are neglected. Just for the reason of understanding, we are neglecting it. So just consider this as a closed container. Before keeping this burner, let's consider this as a closed container here. So here the water, so the matter is present, but and it's in the normal temperature. Now while heating it, we can see that the temperature of this matter increases. So it means that the energy is transferred from from the surroundings to the inside matter. The energy is transferred. So but we can see that mass is not transferred. Please keep in mind, mass is not transferred, energy is transferred. So this is the example of closed system. As you can see that heat transfer is taking place but mass transfer does not take place. While heating with the burner, heat transfer takes place but mass transfer does not take place. So this is the example of closed system. Next, let's move on to the next system, which is open system. So in the open system, what is open system? Open system is nothing but system in which both mass transfer and heat transfer can take place. In this mass transfer, mass is moved in, mass is moved out. Heat, you can say it also as energy. As I said before, heat you can say it as energy. So energy can be moved in, energy is moved out. So in this, both mass transfer and heat transfer takes place. So this is the example of open system. For example, consider a turbine. So in a turbine, you can see that this is the diagrammatic representation of turbine, which you'll be learning it further when you move on to the upcoming videos. So in this turbine, you can see that heat in turbine normally what will be flowing, the heat and the water vapor. Which water vapor normally steam we used to say, no, the steam is moved in, and also the heat is also moved inside. So in and after this when it rotates this fan, and for a fan we have to rotate the generator. After that purpose, the heat is went out and also the steam, that is the matter, also goes out. So heat is moved in, the energy and matter is moved in, and that energy and matter after the process is moved out. So where it is moved out, it's lost to the surroundings. Normally the interaction between the system and the surroundings. Always keep that in mind. So it is the interaction between system, and so it is lost to the surroundings. So lost to surroundings. So this is the example of open system. And in most of the applications, if you see air compressor also, most of the application, engineering application, are open system. Okay, always keep that in mind while learning any problems. All the open systems, and most of the engineering applications are open systems. So let's move on to the next one, that I think you all may have found. What is that? Isolated system. So isolated system is nothing but, you can see that this is a system. Here you can see mass transfer, heat and weather both will take place. Not at all. Both mass transfer and heat transfer will not take place in isolated system. So in this system, as you have seen, it is represented by small dashes insulating. This is for insulation from the heat. So it means that heat can't be transferred, heat can't pass inside and heat can't move out. So it will be fixed. The heat will be fixed, mass will be fixed, but mass transfer, heat transfer will not take place in isolated system. So this is the example of isolated system. Let's move on to the next concept, which is control volume. This control volume, it will be applicable only for open system. So, and for what purpose this it is applicable for analysis of the open system, this control volume concept is there. So what we define as control volume, it is defined as certain volume in space. It's simple, certain volume in space. For example, let's move on to the example to understand this. So in this example, you can see that this is the air compressor. In this air compressor, I have seen by the red dotted lines, you can see here, this is the fixed, the certain volume that is fixed. See, this volume is fixed. As air moves in, air moves out, and that process takes place. But here the certain volume, it always remains constant. This volume always remains constant. Even though this process takes place, the volume here, the certain volume remains constant, and that certain volume in space is known as control volume. Sorry, it's not constant. Certain, they are defined as certain volume in space. So you can see here that it is a certain volume, that is the known as control volume. So next one, let's move to the properties of system. So in properties of system, it's nothing but the physical, normally while understanding it, you would have understood it's nothing but the physical characteristics of the system, such as, for example, pressure, volume, temperature. As you know in the earlier courses, properties of system, these are completely it is known as, you are known in the before classes. So properties of system is nothing but physical characteristics of the system. For example, pressure, volume, temperature, these are the physical characteristics of the system. So here, so properties of system is nothing but physical characteristics of the system. Example are pressure, volume, temperature, right? Okay. So let's move on to the next one. So in the next one, we can see that in system, we are not moving to the next one. In system, you can see that based on property variations, it comes under the same thing. Based on the property, some system may have definite properties, such as for some system may have definite value of temperature, pressure, volume, and and there may be for that we give terms such as state. And when the one state, when it changes to another state, we call another one more term is used. So like that, many terms are being defined under this, under the based on property variations is defined, such as state, process, path. This and all you will be seeing it in the next video. So next video, it will be the, in that you can see the definition of state, process, path, and many other terms. So I hope all have enjoyed watching this video and all have understood. So if you like this video, I think all would have liked. So if you have liked this video, please share to your friends, those who can't understand, those who are in need to understand these concepts. Please share to them, and also subscribe and like this video. So I hope everyone enjoyed it, and this is Ben Suresh signing off. Bye bye, see you.